Thank you very much. Thanks for the introduction. So welcome to security data science session. And I would take you through the journey of information security and the security data science. And let's start with the number of data breaches in 2016. If you look at the number of data breaches, they are into thousands, 2,000 to be more than 2,000. And this is from Verizon database report 2016. And if you look at here, it takes only few minutes to get into a system. Few minutes, think about it, few minutes. And when you talk about any enterprise, it only takes few minutes, and that's what the data is telling you. And then it takes only few days to exfiltrate the data. So we are in such a grave situation right now. And you talk about the number of countries it got impacted, more than 80 countries. So what is going on here? I mean, you got more than 2,200 or so data breaches happening all over the world, and what are these attackers after? They're after money. 80% of the data breaches are motivated for money, finance, and then rest of the 20% falls into a bucket of nationwide espionage and things like that. So you pick up any company on any of the top 500, at some point they have been hacked. You pick up Sony Pictures and you pick up Target, anyone, they have been breached at some point. Even FBI and some of the national agencies as well. So who are these attackers? Are they very, very sophisticated guys who are writing the code from scratch, or who are they? Well, they are people like us who are doing their day-to-day job. They are going to the market, they are going to the office to hack. And this is at certain part of the countries, certain part of the world where there are not much cyber laws, and they go to the regular jobs to do a hack. They use a lot of security tools. They use a lot of hacks. They use a lot of tools, scripts to get into the system. And they are very, very sharp. Some of them are obviously, their skill level varies, but they work as a team. Now, when we say treasure chest, what are they after? Obviously, they are after the data, customer data. They're after your credit cards, they're after your identity, and they're after the software and also IP of the enterprise. Patents, product architecture, product design documents, and obviously some of the software keys. And guess what happens? Whatever they steal, they put it on a dark net, and they sell it. So credit cards are available on the dark net for some $15, $20, depending on which country it belongs to, and is it how much of the credit limit and things like that. And then identity being sold on even few cents or $1. So this data being sold on a dark net in very easily, and not only that, even anybody wants to hack, they can buy the malware, they can buy the hacks in few dollars. And that is one of the reasons that you see a lot more data breaches, because you don't need to write a code from scratch. And that is what is another reason of a lot more data breaches. Now let me briefly talk about what it goes into these cyber attacks. So obviously it starts with some kind of a phishing attack. So attacker will do some kind of social engineering. They will figure out where they want to attack, what's the profile of people there, who are working there, and then they will shortlist few people and then say that, okay, they'll figure out who are their colleagues, and they'll draft email in such a way that it will look like very genuine. And if one of the click, they put it in the email, and once the user do it, they will put the malware there on the system. And once the malware there, that malware is going to do the job. It's going to talk to the CNC in the back, and then start sending the credentials and sending the data. And the malware is going to, either malware and a combination of the attacker, they will go on to the next one. They will go and steal the next set of credentials. So this journey goes on, and then obviously their target is to get to the data and get to the treasure. Now, why all these security tools are failing? If you look at the current set of security tools, you can pretty much imagine like a fort. So if you go to this fort there, which is in a Jaipur right here, and you picture that in your mind, you have a big walls, and you can't climb it from outside. But you just buy a ticket, and you have authorization to get in, right? Then you can just go in, right? So the same thing is happening to our enterprise network. Our networks are all have the security at the perimeter, and once you're inside, you're free to go. So what attackers typically do is they would do some kind of a phishing attack and compromise a host. And after they do that, they will keep on moving and keep on doing the next privilege access, and they will steal that. And obviously, their target is over the data, and this is what is known as a lateral movement in the industry. And the lateral movement detection is something which is one of the key things for data science, and I will talk about it later on. Now, what we are doing is we are changing the game, and that's what the startups are for, right? So there is a new set of theme which is coming up, and that one of the theme is deception. And deception is being there from thousands or millions of years. We haven't looked at for security. And animals and vegetation, they have been using it for millions of years. And here are two examples. If you look at here, there is a picture, and I don't know if you can figure out, underneath these leaves, there is something hiding here. I don't know if somebody can figure out what is hidden here. It may not be that obvious. You see something over here, three dots. The 3 dots are actually so much blended into the leaves that the predator can't figure out that they are hiding here. Now, if you look at this picture here, and this caterpillar has actually 2 heads, and this one is obviously the real head, and this real head, and this one is the sort of a fake head, and this one also has an antenna. Now, what this one does is, like, if the predator comes in, it's going to confuse, and it's going to eat the rear head, and it will figure out that, okay, it's not able to digest, or it's spit out. So he still has a chance to live. So nature has evolved, and it has learned to deceive the attacker and to deceive the predator. So this has been there in the nature, and there are, like, hundreds of such examples. Some more examples from defense. During the World War II, some of the countries actually built the fake tanks, and those fake tanks were giving an idea to the enemy that particular defense is so strong. They have so many tanks. And guess what? A fake airport with the fake flights were also made to deceive the enemy force. So deception is being used for defense. Now the question is, how can we use it for enterprise security? And not only enterprise security is going to come for the end user security as well. So deception in enterprise, we have to deceive and decoy and also trap the attacker, and that's the whole intention. Now in this one, how do you do it? Like, you have to do it at a multiple level, with a lot of variety. So this is a low interaction. In the low interaction, what you do is you do a deception at port level, or you emulate some certain services, or emulate the operating system, or emulate the databases. And at the high interaction, you have actually full-blown VMs, and those VMs would be actually deceiving the attacker, and they would have the real things. And deception can't be just variety alone. You need to have a density. You need to have also the scale as well, and it should be dynamic and also changeable. So once you have this deception, now how do we tie it with the data science? And this obviously this conference is all about data science. So if you look at the data science for security, it's been primarily sort of modeled around anomaly detection. A lot of data sources are being there, which you use for security data science. So you start with, let's say, networks, network packets, and network logs from your router, from switches, and all the network elements. You take that, and you figure out what's the baseline, and then if you get any deviation from there, you raise some alert, you raise an anomaly. And obviously, firewall is another example where you do more of a rule-based anomaly detection. Then a whole bunch of other data sources are more like end users. From the end users, you monitor each and every user, and then you raise alarms if something is deviating from the baseline. So this whole theme of anomaly detection, how it works out is you start with a whole bunch of models. Either you start from a parametric models or non-parametric models or a change detection, and then you move on to the machine learning algorithms like one-class SVM and maybe a DB scan algorithm and so on. But with this power of computing, you can take this machine learning and now you can boil the ocean for each and every user and for each and every network device and do the anomaly detection. And that's what being called as user behavioral analytics. Now, what's the evolution, what's the journey of this security data science? As I told you earlier, that we started with, as a community, we started from rule-based, and then it is evolved over data mining, machine learning, and then getting into more deep learning as well. So people are applying now deep learning for the security data science. Now, where we are here in the deception trigger data science, what we are calling is, when you do a security data science from boiling the ocean approach, there are a lot of false alarms. Obviously, when you are mining the whole, everybody, every network element, every user, you will get a lot of false alarms. And auditing all of those alarms is not possible. Typically, a security analyst would get around 200 to 300 security alerts in a day. And guess what? How many he can investigate? He can investigate probably 8 to 10. And that's where the data science alone is actually failing. And what we need is a combination of deception and the data science. So what we get into is a deception trigger data science, and that's what the title was, right? So you put the deception there, so in the enterprise, and what you imagine is nobody is supposed to go there, right? And if somebody is going there, that means there is something fishy, right? It's likely to be an attacker. It's a high fidelity alert. You don't need to boil the ocean. And once you take that alert, you construct the context around it. You take all the data which is correlated with that, you take the data from firewall, you take the data from authentication, NetFlow, end user, take it from entire gamut of the data sources, and you construct the context around it, and that will make deception triggered security data science. Now, what this deception triggered data science is going to do for you? It can do a whole lot. First of all, how are you going to actually play out the deception? Now, let me give you a very, very simple example. You got the rats in your house, okay, and you want to catch those rats. Where are you going to put that rat catching device? Where are you going to put that? So the deception has to be played out. Somebody has to guide it, right? If you put thousands of rat catchers, obviously, rats are smart too, right? And they would know that, okay, these are all for me as a trap, right? Another thing is you have to allure them. So you have to put something so that they come there. And if you take that same example, if you're putting a deception in the enterprise, you need to have a data science which is sort of guiding the deception and saying it, hey, deception has to be put here, there, and then the density has to be here, and the type has to be this, and then also it has to allure the attacker. So there is a whole bunch of data science comes into guiding the deception. That's the one aspect. And the second aspect is, as I told you, that once the deception is triggered, what you do, you construct the context around it, and then you say, who's the adversary? Where he came from? I mean, like, you have to construct all those hypotheses and then you start answering them and say that, what's the profile? What's the behavior of